Hello and welcome to my channel. So today let's look at the weekly contest 277. So I actually that is Saturday night. So I have actually completed all the 4 questions within 1 hour, and there is no like a wrong A. So yeah. Uh, so let's go over the last question of this contest. 2151 maximum good people based on statements. There are two types of persons: good person, the person who always tells the truth; bad person, the person who might tell the truth and might lie. You are given a zero-indexed 2D integer array statements of size n times n that represent the statements made by n people about each other. More specifically, statements ij could be one of the following. 0 represents a statement made by person I that person J is a bad person. 1 represents a statement made by person I that person J is a good person. 2 represents that no statement is made by person I about person J. Additionally, no person ever makes a statement about themselves. Formally, we have a statements II is 2 for all i's. So return the maximum number of people who can be good based on the statements made by the n people. So example 1 statements is those, and the maximum number of people who can be good is 2. So this is like person 0 and person 1 can be both good. And so example 2 is 2002 is 1. So actually then we actually should notice this condition. So n is between 2 and 15. So which means we can actually use a binary number to using a 15 digits a binary number is enough to cover all the states. So for example, if we have this state is which means all people are bad. So 0 means people are bad, right? So 1 is this person are good. So if we have 1, like everybody is 1, then all people are bad, good. So what we can do is we iterate through all the states, and then we check if the statement there is any contradiction in the statements with the state. If there is no contradiction, then this is a valid state. Then we can count the maximum good people. So let's get the firstly get the n, and yeah, so then we can define the answers. We can call it 0. So then we need to update if we find a larger one. We find them like have a state higher than the current answer. So we can start from state is 1, and then state is smaller than one shift n digits to the left, and so so then for each state we can iterate through all the digits. So if this person is a bad person, we don't need to consider that. So because the bad person can either tell the truth and might lie. So both the condition is so it means the bad person's what the bad person said is actually doesn't matter. It cannot. It's not decisive. So yeah. So if it's a bad person, we just continue. If it's a bad person, ith digit. Then if it's a good person, then if we come to this step, it means it's a good person. So then we need to check if there is any contradictory. So we go through all the statement of that person, and then we check if yeah, we check if the state is equivalent. Actually, there is another possibility. It's 2, right? So 2 means there is no statement. So let's get us S, so which is the state. It can be 0, 1, or 2. So if it's S is 2, then we just continue. Yeah, we also need to have a Boolean like valid. Then if the state is actually no. This cannot be 2. What I mean is if the statement I j is 2, then we continue. Which means we cannot compare. Otherwise, we can check if it's not S, then valid is false. So we can also break this loop, because we don't need to check this state anymore. So it will be false. So here we can check if state is valid, if it's valid. We can count, do a big count. This will count all the ones in the state. Then this count will be the number of good persons in this state. So in the end, we just return answer. So this should be able to pass, but there is another way we can actually make it a little faster, which is so if the state if the good people in this state is less than or equal to answer, we don't actually need to consider this state. We can just skip this state. So then let's check if yeah. So the first example is correct, and the second example, oh, okay, it's already there. So yeah, so both examples are correct. Yeah, so actually, let's also have a look at the time complexity. So the time complexity here is we have a double loop, and we have actually triple loop. The first loop is state, the second loop is n, and third loop is n. So we actually can the time complexity is about this. So the maximum n is 15. So it's about 2 times 15 times. So the maximum is 2 times 15 times 15 times 15. So actually, you can see that this number is actually about 10 to the power of like 7. So it's about okay with the Leetcode online judge. That's why it has no problem to pass the online judge. So yeah, so this is a example of like bit operations using bit um, using a binary number to represent the state. So let me know if you have any questions. Thank you for watching. See you next time.